Good afternoon, guys. Today we're going to play a quick game called Name That Gut. Yeah, name that gut. And we're also going to play a quicker game called Name That Shape. Okay, name that gut and name that shape. And we're dealing with invert animals. Inverts, of course, have no backbone the way chordates do. They are a rather diverse group of animals, and we're going to start here with the simplest of them all, the sponges, also known as poriferans. Each of those little pores is where food molecules enter their body, hence they are filter feeders. And what kind of gut do they have? None. They are acoelomates, and they don't really grow in any true form. They are asymmetrical, no true shape. Moving on, we have the cnidarians, and my representative for cnidarians would be these corals. Okay, each coral has a little hole there. Each hole, as you can see, I think you can see that pretty well. Each little hole is an individual member of this community. Yeah, each little piece of coral is its own little city, and they're called polyps. So it's a circle in a way. That means it is radial symmetry, okay? And like these sponges, they too have no true gut. So they're acoelomates and radial symmetry, okay? Moving on a little bit here, I want to show you a nematode. So inside of this cricket outcrawled a roundworm, a nematode. So that has a pseudocoelom, but now the shape of the animal has changed. That is bilateral symmetry. You can only cut it in one half. Moving on, now we have the mollusk. Mollusks all have a true gut. They are protostome coelomates. That means their first hole was the mouth, and the anus came second during embryonic development. So that's their gut. Okay, now as far as shape goes, they also have a head, okay, a head that they eat with and so forth. So that means they have to have bilateral symmetry, similar to that nematode over there, okay? So on the top row, you have two gastropods. You have this large conch, which is very beautiful, and then this one's even more spectacular. That's abalone, which is just a beautiful shell, I think. And next to that, you have another gastropod. That is the state shell of Texas, the lightning whelk. Very cool, huh? On the bottom, there's a bivalve, and here's a whole little colony, really, of these bivalves. Two shells, but again, they're still mollusk, and it is still an example of a protostome coelomate as far as gut goes, okay? Then you have the nautilus, and if you recall, nautiluses have a shell, but they are related more so to things like squids and octopuses. So they would be called cephalopods or headfoot. They kind of blow water out of their head. That's how they move. So headfoot, cephalopod, as opposed to gastropods, which means stomach foot if you do the Latin. Now we move on to arthropods, okay? Arthropods are the most diverse phylum of animals, and in particularly, the insects are the most diverse class of any animal on the earth. So all arthropods, again, have a head, so that means they are bilateral. That's their shape. And gut would be similar to those mollusks over there. They have a protostome coelom. So once again, their first hole during embryonic development was their mouth, and the anus came later. Okay, as far as identifying orders, like beetles, and there's another beetle. They're coleoptera. We'll get more into that in class. Now I just wanted to show off this big old katydid. That thing is ginormous. It's like the Mothman, if you were familiar with the Mothman. Good movie if you haven't seen it, but I digress. So there you have a few insects. These are barnacles. Barnacles are the only crustaceans, the only arthropods that make their own shell. So you might be wondering about some of these crabs. They don't make their own shell. They steal it from gastropod mollusk. And then I'll show you this. Scorpions are really cool too. When you put a black light on them and they light up, it's pretty cool. I'll talk more about that in class. Finally, we get to echinoderms. Echinoderms might be the most unique ones up here. Okay, so in some ways they are highly evolved. In other ways, they've kind of have gone backwards. All right. So take a look at the sand dollars and the sea stars, and there's a sea urchin. These guys are a type of radial symmetry. So you remember the word radial symmetry way over here near the beginning of my animal life? Radial symmetry, right? And lo and behold, they've kind of gone backwards. It's kind of like retroevolution, to use a term from a previous unit. So those sea stars there, you see 5-part radial symmetry. So the shape is a little backwards, but these are the first guys to have a deuterostome coelom. So that means they're more like us in terms of their gut development. So what does it mean to be a deuterostome? That means their first hole during embryonic development is the anus. The mouth, of course, comes later. Again, things we'll talk about in class. Finally, last but not least, since I was taking stuff out of the display case, we're wrapping up plants right now in my class, so I just thought I would show you this chunk of a tree trunk and remind you that we'll talk about how to count tree rings another day. And that's about it. I wanted to keep it under 6 minutes, and I just about did it. So, guys, God bless you all. Have a great day, and I will see you in class in about 15 minutes. Bye-bye.